Hello everyone, welcome to our class for today. Today we will be going over lesson 9.8, which is trig word problems, and we will be utilizing the trig ratios that we have been working with from the last two sessions. So let's get started. First we'll look at example 1, and let's read it. When the sun's angle of elevation is 57 degrees with the ground, a building casts a shadow 21 meters long. How high is the building? So the first step to solving these word problems is drawing a picture. Now earlier we learned about angle of elevation and depression. Remember, angle of elevation starts at the horizon and we move up. And this would be considered our angle of elevation, and this would be 57 degrees. Now, it said that the sun was at an angle of elevation of 57 degrees, so our sun will be here. And the building casts a shadow 21 meters long. So remember, or if you recall, when you're outside and a sun casts a shadow, the shadow is behind you. So the building shadow is over here. And we know this building shadow is 21 meters. Okay, we want to know how high the building is, which means we want to know its height. Now from here, we have a right triangle, and we just have to label our sides. So our angle is 57 degrees, which is over here. X would be opposite, and our 21 meters will be adjacent, which means we will be using TOA, which is tan. So tangent of 57 is equal to opposite, which is x, over adjacent, which is 21. Then we multiply by 21 on both sides to solve for x. To solve for x equals 21 times tan of 57. And if we put that into our calculator, we would have x is equal to 32.3 meters. Now remember, because we're working with word problems, we have to include our units. Okay, let's look at example 2. A blimp hovers over a stadium 125 meters high. So if this is our blimp, it's hovering over a stadium, football stadium or baseball stadium, at 125 meters high. The pilot sights a tennis court at 8 degrees angle of depression. So here we're working with an angle of depression. And our pilot is up here, so his sight starts at the horizon, and then he looks down at a tennis court, which is over here, at an angle of 8 degrees. Now we want to find the ground distance in a straight line between the stadium and the tennis court. So we are actually looking at this. Our right angle is here because we are looking straight down and across. Okay? Now we need to find that ground distance, so this would be our x. Okay, but right now we don't have the angle inside the triangle, but we know that from geometry that interior alternating angles are equal to each other. So this angle right here is 8 degrees. So this 125 to that 8 degrees is opposite, x is adjacent, so again we are using tangent. So we have tangent of 8 is equal to 125 over x. Multiply x on both sides. X times tangent 8 is equal to 125. Then we divide by tangent of 8 on both sides. Then we get x equals 125 over tangent 8. Now to find x, we use our calculator, and x is equal to 889.4 meters. Okay, so at this point, I'd like everyone to try practice 1, and I will help you draw out the picture first, and then you can use or do the calculation yourself. So a kite is flying at an angle of elevation about 40 degrees. So if we're here, we're flying a kite up here, and with the ground, we make a 40-degree angle. All 80 meters of string have been let out, which means that this is 80 meters, and we want to find the height, which is x. So from here, go ahead and write out the correct trig function or trig ratio that we will use to solve for x, and then give me the answer of x. Okay, and hopefully everybody was able to get 51.4 meters. Now in practice 1, we did use sine because we were given the opposite and hypotenuse. Now let's do practice 2. I would like you to draw the picture this time. Okay, hopefully everybody was able to get a picture kind of like this. So now let's write out our trig ratio. Well, first we have to make sure that we include our angle 28 degrees down here. Remember, interior alternating angles are equally to each other, so these two angles are equal to each other. And then we label x is opposite and 50 is adjacent to 28 degrees, so we will be using tan. So tan 28 equals x over 50. Now go ahead and solve this for x. Now I hope everyone was able to get x equals 26.6. Now let's move on to example 3. Should be written as example 3. So let's read it first. A ladder is leaning against a building. So let's draw that. So we have a building, and then we have a ladder leaning against it. The building is 14 meters high, so this is 14 meters, and the ladder is 19 meters long. What is the angle of elevation that the ladder makes with the ground? So our ground is here, and we are looking for this angle. So first, let's label our sides with opposite, adjacent, or hypotenuse. 14 is opposite, 19 is hypotenuse. So we are using sine. We don't have our angle, so we will have our angle be represented by x. And this equals opposite, which is 14, over hypotenuse, which is 19. Then again, like last lesson, we will use the inverse to solve for x. So sine inverse will be applied to both sides. Sine inverse and sine cancel out. So on left we have x. And that equals sine inverse of 14 over 19. Then we use our calculator to solve that out. And that gives us x equals 47 degrees. Now I would like everyone to try practice 3. Everybody was able to get x equals 43 degrees. Now remember, for a slide, the ladder goes vertically. So here, the ladder is this 9. And then the slide will be our hypotenuse.